Hi students, and welcome to today's lesson. I'm Mrs. Baidani. Today we will explore the question, how do the properties of solids, liquids, and gases compare? Are you ready? Grab your pencil and your science journal, and let's get started. We have been investigating the properties of solids and liquids, but in our last lesson, we explored another kind of matter, gas. We still have more to learn about the properties of gases. Once we have more information, we can compare gases to solids and liquids. What happened to the shape of solids and liquids when we poured them into different containers? The shape of the solids did not change. But the shape of the liquids changed to take the shape of the new container. Do you think we could observe the shape of gases in the same way we did for solids and liquids? I don't think so. We can see solids and liquids, so we are able to observe their shape. There are many gases that we can't see. What other senses could we use to observe gases? Sometimes I can hear the wind blowing. Maybe we could use our sense of hearing to observe gases. Or maybe we could use our sense of touch to feel gases. I know I can feel cold air when the air conditioner is on. Oh, I have an idea. Maybe we could use our sense of smell. Imagine you were sitting in the back of the classroom. Your teacher is all the way in the front of the room standing behind a table. You notice a covered beaker on the table. Your teacher tells you to observe what happens when she opens the beaker. She instructs you to sit silently and raise your hand when you smell something. Then your teacher opens the beaker. After about a minute, you see the students in the front row raise their hands. You sniff the air, but you don't smell anything. Another minute goes by, and your classmates in the second row and the third row raise their hands. But you still don't smell anything. Finally, after about 3 minutes, you smell something. You raise your hand. What did you notice about what happened? Maybe you noticed that the students closest to the beaker smelled something first. Did you notice that you, as the student in the back of the classroom, smelled something last? What type of matter do you think you and the other students were smelling? Do you think you were smelling a gas? I think so too. You can't see the smell, but you can smell the smell as it spreads through the room. I have an idea. Let's draw a model to explain how the gas moved from one side of the room to the other. Our model will have 3 rows. In the first row, we will draw what happened when the teacher opened the beaker. In the second row, we will draw what happened after 1 minute. And in the third row, we will draw what happened after 3 minutes. We will draw the teacher, the table, and the beaker with large red dots to represent the gas particles. We will also draw 4 rows of students in each row of our model. What else should we include? Oh, let's include air particles. Air is everywhere, so we will draw small black dots to represent particles all over in each row of our model. Great! Now what happened when the teacher first opened the beaker? Well, some of the gas particles probably escaped from the beaker. But none of the students could smell the gas yet, so we will only draw gas particles right near the opening of the beaker. Remember, the gas particles are larger and a different color than the air particles, so we can easily see the difference. What happened after 1 minute? After 1 minute, the students in the first row could smell the gas, right? How can we show the students in the first row smelling the gas? Do you think we should add more gas particles? I agree. Let's show the gas spreading from the beaker to the students in the first row. And let's show the students raising their hands. What happened after 3 minutes? Well, after 3 minutes, all 4 rows of students could smell the gas. So what should we draw? Let's draw gas particles spread out all over the room. And we can draw all students raising their hands because they all smell the gas. Is our model missing anything? Oh yeah, our model is missing an explanation. After today's lesson, you will draw a model to explain how the gas moved from the front of the room to the back and write an explanation for the model. So in our imagined event, the gas was originally in a covered beaker. The beaker was the container for the gas. And when the teacher opened the beaker, the classroom became the new container for the gas. The gas spread throughout the room and filled the whole space. What can you conclude about the shape of gases? I don't think gases have their own shape. Do you agree? I think gases take the shape of whatever container they are in, just like liquids. Now imagine that a beaker is filled with a liquid instead of gas. What do you think would happen if I poured the liquid out of the beaker and into a classroom? Would the liquid spread throughout the classroom like the gas did? No. The liquid would spread a little, but the volume of the liquid in a beaker would not be enough to fill the classroom. The volume of a liquid is stable. The volume does not change when I pour the liquid out of the beaker and into the classroom. But wait, do you think the volume of the gas in the beaker changed when the teacher opened the beaker? I think the volume of the gas did change. At first, the gas was the same volume as the beaker. But then the gas spread throughout the classroom, so the volume of the gas must have increased. Unlike the stable volume of a solid or liquid, the volume of a gas can change depending on the container the gas is in. A gas is the type of matter that has a shape and volume that changes depending on the container it is in. When the gas left the beaker, the shape and volume of the gas changed to fill the new container, the classroom. Remember, we have been exploring the question, how do the properties of solids, liquids, and gases compare? Let's add what we've learned to our class chart. I think we need to change the title of our chart, don't you? Let's change the title from Properties of Objects and Materials to Matter. And I see another change we need to make. We wrote size, shape, and mass are properties of objects. Let's revise that to say size, shape, mass, and volume are properties of objects. Great! What else can we add to our chart? Let's say that solids, liquids, and gases are different types of matter. And let's also add that solids have a stable shape and liquids and gases take the shape of their container. For one of your tasks today, you will update the class chart. What do you think the video clip shows? Do you think the video clip shows ice melting? I agree. the 2 ice cubes became liquid water. Why do you think the solid ice turned to liquid water? I know that when ice gets warm, it melts. And when ice melts, it turns to liquid water. So one type of matter can become another type of matter. We will explore the relationship between different types of matter in our next lesson. Let's review your tasks for today. First, draw a model to explain how the gas moved from the front of the room to the back. Second, write an explanation for the model. Third, update the class chart.